I am Dr. B. Ravikumar, Associate Professor, Department of ECE, Institute of Aeronautical Engineering. In this lecture, I am going to explain about switching functions and the canonical standard forms. A Boolean function or switching function is made up of Boolean variables. What is Boolean variables? A Boolean variables, it contains the range of values are 0 and 1. A Boolean function is an expression formed with the binary variables, the two binary operators, OR operator and AND operator, unary operator, not, parenthesis and an equal sign. These are all combining together to form a Boolean function. Example, f1 is equal to x, y, z bar. X, y, z bar, here we can see three variables x, y and z bar, and the x, y, z are make with the AND operation. They are like look like a product term. Sometimes some other Boolean functions may have these kind of AND operations or AND terms combined with the OR term or complement term. So the function f is equal to 1 if x is equal to 1, y is equal to 1 and z bar is equal to 0. In this case, that function generate the output 1, otherwise that f1 is equal to 0. Generally, the Boolean function output may give two possibilities of outputs, either 0 or 1. And a Boolean function which is represented with this kind of Boolean expressions and operators is the one way. The Boolean function may also be represented in truth table. In this truth table, we can take the input column and the output column. To represent a Boolean function in the truth table, it has 2 power n Boolean logic and logic 1 and 0 combination, 2 power n. For n variable, for n variables. The example for truth table of any Boolean functions, you can see here. In this truth table, we can use a variable x, y, z and a Boolean 4 different kinds of Boolean functions f1, f2, f3 and f4. In order to make this table for the 3 variables, we require 2 power 3, which is equal to 8. 8 Boolean combinations, 8 Boolean logics 0 and 1 combinations, 0 to 7. So the Boolean values are start with 0 in decimal number and end with 7 for 3 variable. These combinations of Boolean variables x, y, z, corresponding output will see in the f1, f2, f3 and f4 Boolean functions. As I said, these 4 Boolean functions can be expressed either Boolean variables or in truth table. In this truth table, if you see f1 output is equal to 1 when x is equal to 1, y is equal to 1 and z is equal to 0. Otherwise, the entire all combinations of inputs that for particular function f1 is equal to 0. Similarly, if you see f2 having almost 5 ones are there. 5 combination of inputs. One combination is 0, 0, 1, x is equal to 0, y is equal to 0 and z is equal to 1, f2 is equal to 1. And here other 4 combinations. For these combinations of input, that f2 shows output 1. Likewise, function 3 and function 4, which gives the corresponding logic high for the combination of input logics. The mathematical Boolean expression of these functions f1, f2, f3, if you see here, that function f1 is equal to x, y, z bar, and function f2 is equal to x plus y bar z. So these Boolean expressions can be represented in this table. In this case, that Boolean expression x, y, z bar is the only case that f is equal to 1, x is equal to 1, y is equal to 1 and z is equal to 0. 0 means 0 bar. 0 bar is equal to 1. The product term of x, y and 0 bar is nothing but 1 into 1 into 1. You will get f1 is equal to 1. The remaining all case you will get output is equal to 0. Function f1 is equal to 0. And f2, in the f2 case, suppose a variable x is equal to 1, irrespective of this y bar and z is equal, irrespective whether it is 0, 1, 1, 0, all cases 0, 0, 1, 1. So irrespective of this y bar and z, if x is equal to 1 is there, then output is equal to 1. Where is the case for x is equal to 1? The x is equal to 1 in the f2 here, if you see here. So here x is equal to 1. So whatever the combination 0, 0, 0, 1, 1, 0, 1, 1, all case that f2 is equal to 1. And some other case, so here if you see here, x is equal to 0, y is equal to 0, z is equal to 1. X is equal to 0. Suppose that x is equal to 0, which depends on y bar and z. What y bar? It is a complement term. So y bar is equal to, y is equal to 0. So y bar is equal to 1 and z is equal to 1. 0, 0, 1 case also you will get f2 is equal to 0, 0, 1. Will get f2 is equal to 1. And a Boolean function f2 is equal to f3 is equal to x bar y bar z plus x bar y z plus xy. If this expression, if you substitute different variables, you will get the output for the f3. So one case is 0, 0, 1 and 0, 1, 1 and 1, 0, 0 and 1, 0, 1. For this case, we can get a Boolean function value is 1, remaining value is 0. And this expression, the Boolean expression for this column f3 or output f3, can also possible to minimize it. So we can also represent it with other Boolean functions. So which consist of, so as we studied about some Boolean theorems, axioms. So by applying these theorems here, that x bar and y bar, like x bar z and y bar, x bar z, factor out this x bar z, separate this x bar z with this first two terms. So z y bar plus y. We know that y bar plus y is equal to 1. So this will be 1. So we will get x bar z y bar plus y is equal to 1. X bar z plus xy bar. The Boolean function which we get based on the like redundance in the expression, you will get x bar z and xy bar also. When we take this f3 expression, x bar z and xy bar z is also gives the same truth table column what f3 we get, but two different Boolean functions. So that is that some case we can also possible to get one in the truth table a same output column having two different kinds of Boolean functions. And for xy bar and x bar z, xy bar x bar z, in this case, so some here also we can get four different combinations of input. Will get logic 1 and the remaining values are logic 0. So that is what a Boolean function can be represented. So Boolean function can be represented in two ways. One is direct representation of Boolean expressions using the variables, operators. That left side represented with the function is equal to the Boolean variables and operators. We can represent it this Boolean function or switching function. And another way is to represent a Boolean function is truth table by giving for n variable 2 power n combinations of logic 1 and zeros start from 0 0 to 2 power n minus 1 in binary form, and then corresponding output column in the truth table based on the terms which are existed in the Boolean expression. So corresponding output is logic 1, the remaining value logic 0. This is the manipulation or like implementation of those Boolean functions. So still now we didn't study about logic gates, but just I am explaining how to connect those Boolean functions diagrammatic form. So f1 is equal to xyz. So if we take the AND operation, it is a totally AND operation, and totally AND operation, so we need one AND gate, and there is one term complemented term z bar, so we need one inverter. That inverter operator is represented with a symbol buffer with a bubble. So z input is given to that inverter, will get z bar. The remaining value input is x and input y. So both are, these three variables are in product form. So x, y, z bar connected in 3 input AND gate, you will get x, y, z bar. f2 is equal to x plus y bar z. That means, so here we can take the x plus y bar z. So x is another term. So first we make the AND operation of y bar z. Y bar is the inverter operator. So y is input and y bar will get output. This y and another z input is a product term, will get AND gate. And this AND gate is operated with the x plus y bar z will get f2. So in this way we can connect this gate. Next f4 is equal to x y bar plus x bar z. This is one gate AND gate. This is another AND gate. One complementary term, another complementary term, 2 NOT gates, and then one OR gate. So we need one OR gate. OR gate, AND gate, AND gate, NOT gate. So xy bar plus x bar z. Take the x normal x. Take the normal directly x value, and then y bar will get using inverter will get y bar, xy bar, because it is a product term, so we need AND operation. X bar z, that x input is passing through the NOT symbol, and will get x bar, and z is directly given to AND gate. You will get x bar z. Then we connect it to OR gate. We'll get xy bar plus x bar z. Similarly, this is the 3-level gates: x bar y bar z plus x bar y z plus xy bar. So how many terms are there? Product terms. So but these are connected a single OR gate. Next, coming to canonical and standard form of Boolean functions. A binary variable may appear either in its normal form, for example, a variable x and a variable x bar. If it is r bar, if it is y bar. And two binary variables, let us take x and y, combining with an AND operation. When we combining with the two variables x and y, AND operation, since each variable may appear in either form, complemented and uncomplemented form, there are four possibilities. There are four possible combinations which are called x bar y bar, x bar y, xy bar, and xy. These expressions similar when we represented in similar with the logic values. So x value and y value represented in four combinations. One is logic 0, logic 0, logic 1, and logic 1, logic 0, logic 1, logic 1, logic 0, 1, 1. So when we represented in a variable form, so this x corresponding 0 means it is a complemented form, and 0 means complemented form of y. So x bar y bar, x bar y, and x y bar, wherever 0 is there, it's corresponding to complemented form of that variable, and x y. These four combinations. So each of these four AND terms is called min term or standard product. So each combination of this variable, two variable, x bar y bar, x bar y, xy bar, and xy. So each term form with AND operation, x bar dot y bar. So each of these four AND terms is called min term or standard product. Similarly, a symbol for each min term, a symbol for each min term is of the form m suffix j, where j denotes the decimal equivalent of the binary number of the min term designated. If you see here, represented with the min terms mj, when j is corresponding to 0, we will get a min term 0, m0, it is corresponding min term, the min term m1, m2 min term, m3 min term. So here, when we substitute j is equal to 0, 1, 2, 3, you will get four kinds of min terms. Similarly, n variables forming an R term, with each variable being primed or unprimed, provide 2 power n possible combinations called max term or standard sums, which is called standard sums. If, for example, if you take a 3 variable combination or 2 variable x, y, these x, y are the 2 variables. Since these x and y variables are available in a complemented and uncomplemented form, then what are the max terms representation? The variables are being represented in max terms when we forming with an OR operator. 0, 0, and here 0, 1, 1, 0, 1, 1. x bar, y bar, x bar plus y, we can represent it 0. That unprimed value x plus y, x plus y bar, x bar plus y, x bar plus y bar. This plus represents the under term for the two variable Boolean function. The variables range from 0 and 1. So there are 2 power 2 combinations will come in the Boolean truth table. So to represent a two variable forming an R term, each with each variable being primed or unprimed, provide 2 power 2 possible combinations, which are called max terms or standard sums. X plus y, x plus y bar, x bar plus y, x bar plus y bar. If you see a three variable Boolean function represented, a three variable function represented in a table in min terms and max terms. If it is three variable, n is equal to 3 means 2 power 3 is equal to 8 Boolean combinations, which are represented as 0, 0, 0 to 1, 1, 1. 0, 0, 0 to 1, 1, 1. Corresponding Boolean combinations 0, 0, 0 to 1, 1. What are the min terms and what are the max terms, or what are the standard products and what are the standard sums? The first we will see standard products, which is called min terms for this three variable combination. So this a variable corresponding variable, the logic value is 0 means it is a complemented form. So we can represent 0 as a bar, b bar, c bar. So both three variables having complemented form. So that input Boolean function is Boolean logic value is 0, a bar, b bar, c bar, which is represented as this represented with m0, m0. That min term represented with a small m suffix 0. 0 represent that corresponding binary combination in represented in decimal number 0, 0. And second combination 0, 0, 1 we can represent it with the min terms a bar, b bar, c. So it is a combination logic decimal 1. So m suffix 1. Likewise, we can represent it with a bar, b, c bar is equal to m2. A bar, b, c is equal to m3. A, b bar, c is equal to m4. A, b bar, c is equal to m5. A, b, c bar, m6. A, b, c is equal to small m7. Small m7. Similarly, those Boolean expressions of 8 combinations can be represented with the max term. This max term, in this max term we can take R operator. The max term nothing but these variables are combined with the R operation, like plus symbol. Let us take in this max term representation, 0 is represented with a variable, direct variable, and 1 represented with a complemented variable. So 0, 0, 0 means a plus b plus c, which is equal to, in max term we can represent with capital M suffix j, min term represented with small m suffix j, where j is equal to, substitute j is equal to 0 to 7. you will get 8 minterms. So which is represented with the M0. Next 001 means uncomplimented A variable A, uncomplimented variable B, and complemented variable C to represent 1. So it is a max term. We can represent capital M with the suffix 1. Likewise, we can represent this entire table for M2, M3, M4, M5, capital M6, capital M7. A dash plus B dash plus C dash. So in this, any variable can be represented in terms of min terms and max terms. A Boolean function represented with the variables. Variable is formed using min terms and max terms. So these are all combinations of min terms and max terms. So 8 combinations of min terms and 8 combination of max terms. So we can also represent it with a Boolean function, not only using all the min terms and all the max terms. A Boolean function can be represented with a single variable or 2 variables or 3 variable functions. So if you take this expression, if you take this table, in this table, 3 variable functions, the functions are called f1 and f2. A 3 variable combination, variables are 3 means 2 power 3 means 8 combinations of input binary values 0, 0, 0, 2, 1, 1. So what is the Boolean function for this f1 is where the logic 1 is, wherever the logic 1 in the output corresponding combination, input combination of term called minterm is nothing but Boolean function. So f1 can be represented with f1 output in which logic 1 is the logic 1 of corresponding minterm. This is called minterm. So what is the minterm for logic 1 in the f1 is, one minterm is 0, 0, 0, 1. Another minterm is 1, 0, 0, 0, 0. Another minterm is 1, 1, 1. So these are the input Boolean input binary values. Its corresponding representation of Boolean function is, so in the, it is a minterm representation. In the minterms, we can use product standard product. In this standard product or minterm, we can represent a logic 0 is represented as complemented variable and logic 1 represented as uncomplemented variable. So the f1 is on left side, the variable start, the order of the variable is equal to y, x, y, z. That means first logic value is x, second logic value is y, third logic value is z. So we can represent in terms of minterms. So in the minterms, 0 represents complemented value for the first x bar and y bar z, plus we can represent another one x, y bar, z bar, plus x, y, z in the last term. So in this case, we can represent that Boolean function x is there any common term, we can extract that common term also if it is there. If it is not there, we can take that one. We can keep that expression as it is. So next f2 is equal to x, y, Z is the order of the variables, and here it is combination is 4 terms. So in this 4 terms, what is the boolean value for the combination? This one 0 11 5 6 7. 0 11 means x bar y z, x y bar z plus x y z bar plus x y z. So this is the Boolean functions represented in min terms and max terms. Here this representation is called canonical form. Canonical form. In this canonical representation, each term in the Boolean expression having all variables. So it is a 3 variable Boolean function which consists of 3 variables in each midterm. 3 variable in each midterms. If you represented as a max terms, so 3 variables in the max terms. This representation is called canonical form. In the canonical form, each minterm or each max term, all the variables of the function. So the same Boolean function f1 can also be represented in max terms. How to represent this one is in max terms. So here, if you also represented, first we will see this f1. f1 is equal to f1 of xyz can also be represented with a simple representation of these minterms with the symbol sigma small m of what are the input combinations which exist for the corresponding function f1 is 0 0 1. 0 0 1 represented with 1 and corresponding output this one 4 and 7 1 4 7. This is the one other way to represent a Boolean function in terms of no decimal number in the decimal number representation. This in terms of decimal number for the minterms. f1 of xyz is equal to sigma m 1 comma 4 comma 7. Similarly, f2 is equal to f2 of xyz is equal to what is the combinations for f2? f2 combination one output logic 1 is equal to combination of 0 11 means sigma m is equal to 3. Another one వచ్చేసి 101 means 3 5 6 7 3 5 6 7. So this minterm can also be represented. This the canonical form of the Boolean function can be represented with this mathematical equation sigma m is equal to m of 147. Once f1 is equal to sigma m 147, in a similar way f1 is represented in max terms xyz. The max terms means remaining values of the minterms. What are the remaining value for this Boolean function? Sigma capital M, or we can represent it with pi m. Here symbol used for the max term is pi m. So other than this 1, 4, 7, we can take as a max terms. So 0, 0, this one is 0, 1, 2, 3, 5, 6 for the F1 expression. F2 of XYZ in the max terms we can represent with the pi m. What are the representation of max terms in the F2? So we can take 0, 1, 2, 4, 0, 1, 2, 4, 0, 1, 2, 4. Now we will see that express the Boolean function f is equal to a plus b bar c in a sum of minterms. In a sum of minterms, in a product of max terms. So if here in this the Boolean function is in a standard form. Standard form means in this case each minterm having one variable or two variable or more than two variables. But in a canonical form, each minterm consists of all those variables. If it is a three variable Boolean function, each minterm consists of all three variables either in normal form or complemented form. So in order to get express this Boolean function in a sum of minterms, so we can, if we want to represent a minterms, so we can make them each term which consists of all variables. So if you see here a, first minterm a. So by seeing letter a, we cannot find out which minterm it is. So we need to convert that Boolean function each term into a canonical form. How to convert this Boolean function, standardized Boolean function into canonical form? To convert this standardized Boolean function into canonical form, write down the missing term. What are the missing terms in the a is equal to b term and c term is missing. So make those add those missing terms. F is equal to a. So what are the missing terms is b and c. We can write down b plus b bar. B plus b bar is equal to 1. So in order to write down a is equal to a into 1, so we can write down a 1 can be written as b plus b bar. So a, b, if you a take inside ab bar. Again this terms missing c term. So provide that c term. This can be written as ab into 1, ab bar into 1. So that 1 can be written as that along using missing term c. 1 can be written as c plus c bar plus ab bar. That 1 can be written as c plus c bar because c term is missing. In order to include that c term, replace according to Boolean theorem, 1 can be written as c plus c bar. So you will get by inserting that ab term ab inside the c plus c bar abc and abc bar term and a b bar c plus a b bar c bar. This is actually convert this a term into canonical form. Again we have a second term. In this second term, this is actually first term. In order to convert this second term, again we have add the missing variable. The missing variable in the second term is a, b bar c into a plus a bar. So this a plus a bar, this term we can written as b bar c a plus b bar c a bar. So totally how many terms? This is second term. This is first term. By combining first terms minterms and second term minterms, we can get the total minterms for the Boolean function that express the Boolean function in a sum of products. So here, is there any repetition in the terms? We can avoid those repetition minterms and then combining together to get the total minterms, sum of minterms. ABC, ABC bar, AB bar C, AB bar C. Here it is A, B bar C, one term and another term. So according to, if I am writing this expression ABC, ABC bar plus AB bar C here and here, AB bar C. So this can be written as like in bracket, and AB bar C bar plus A bar B bar C. So this is like a plus A is equal to A theorem, according to theorem. So A plus A is equal to A. Likewise, A variables with the R operator with the same variable. So we'll get that's one single term. So ABC plus ABC bar plus A B bar C, A B bar C, A B bar C, A B bar C bar plus A bar B bar C. So just now we studied about what is the corresponding Boolean values for this variable. A variable can be represented in complemented and uncomplemented form. In minterm expression, a Boolean function which consists of minterms, that variable, complemented variable is equal to 0 and uncomplemented variable is equal to 1. So in order to represent that one, it is ABC means uncomplemented value, logic 1, logic 0. So ABC logic 1 and AB logic 1 1 and C bar nothing but 0 and A 0 1 101 plus 1 0 0 plus 3 0 0 1. Its corresponding digits in the decimal. So we can represent that minterm representation. So what are all the values? 0 0 1 means 1 and 1 0 nothing but 4 1 4 and 104 nothing but 5 and 110 nothing but 6 and 111 nothing but 7. So we can represent this Boolean function in terms of sum of minterms. So this is called representation of sum of minterms. F is equal to sigma m of 1, 4, 5, 6, 7. Similarly, how can we express this Boolean function in max terms? How can we express this max term? A plus B bar C. F is equal to A plus B bar C. So we can represent this Boolean function in max terms. In order to get this max terms, find out the complement of F. What is the Boolean function? First step is find out this Boolean function in a canonical form. In the canonical form, we can get ABC bar by applying the missing terms in first term BC and second term A. You will get this max expression ABC bar, ABC bar A B bar C, and then A B bar C bar, A B bar C bar, plus A bar B bar C. Okay. So in order to represent this max term, so this is min term representation, sum of min terms. Now we can represent with the product of max term. Represented with the product of max term. So we take the complement of this one. When we take the complement of this one, ABC, ABC bar, AB bar C, AB bar C bar, A bar B bar C. So De Morgan's theorem, we can apply De Morgan's theorem. De Morgan's theorem. So this is first term, for example, X, this is Y, this is Z, like if you take that one, so ABC whole bar into ABC bar whole bar. So sum of terms complement is equal to individual complement in product. Sorry, ABC bar dot AB bar C whole bar dot AB bar C bar whole bar dot A bar B bar C whole bar. Again, we can apply the De Morgan's theorem to the each min term. So we will get A bar plus B bar plus C bar, in bracket we can represent. Then A plus B plus C double bar, A bar, B bar, already bar is there. So in order to, in the process of expanding this ABC product in using De Morgan's, you will get C bar bar, C double bar means uncomplemented term, into A bar plus B double bar means B into C bar, A bar plus B plus C bar into last term A double bar means A plus B double bar means B, C bar. In max terms, we know that we can represent it with the max term. Bar means 1. So here it is. What are the max terms? Min terms in this 1, 4, 5, 6, 7. So this case, it is a complement F bar. So in order to get this one, so we will take the A plus B plus C, A plus B plus C bar, A plus B bar plus C, A plus B bar plus C, A bar plus B bar plus C. So which is represented as in max term 0, 0, 0, 1 means 1, 0, 1, 0 means 2, 0, 1, 0 means, sorry, here it is A, B bar, C bar, that means Here it is C only. A bar, B double bar, C bar, A bar, BC, A bar, BC. It's A bar, B bar, C. 0, 1, 1, 3 and 1, 1, 0, 6. So we can represent max term is equal to 0, 1, 2, 3, 6. 0, 1, 2, 3, 6. This yes, this can be this canonical form represented in two ways. One is sum of minterms, and another one is sum of max term. And another one is standard form. One is represented with SOP, sum of product, and another one is POS. In standard forms, so each SOP and POS can be represented with a single variable or multiple variables in each minterms or max term. But in canonical form, each minterm or max term must be included. How many variables are there in the function? All variables existed either in complemented or uncomplemented form. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.